It's probably appropriate that I'm presenting on maintenance inspection because I'm getting a little nervous now. As over the past 2 months, I've had about 12 of these things installed across the state, various designs. And not to get back into the design of these, but there's so many things you could do to make sure that your bioretention basins are designed in a way that are going to ease your maintenance burden going into the future. And I think the majority of you guys are going to be reviewing these plans. I think that's what I saw early on. And most likely, you're going to be dealing with sites, maybe on a half acre or smaller, where it's going to be more difficult for the engineers to design these things to be easily maintained. And a good example of that, I don't know if you recall, there was a picture that Leslie showed earlier that showed basically it's a bioretention basin in between buildings. And there was a large riprap basin up front, and you could see more riprap going down the perimeter of that, and that's where the roof drains are coming from. Oddly enough, that's from my old school, one of their new buildings, NC State. It was a lot nicer than when I was there. They had a brand new campus, so I'm a little jealous. But you'll probably be dealing with sites that are going to be designing these bioretention basins in a very small area. They don't have a lot of room to work with. Ideally, if you do have room, you can discharge into a vegetated swell where you're going to get a lot of that sediment pulled out just in that flow to the bioretention basin. Because I know a lot of you guys have concern about that clogging. I always hear about when is it going to clog, when are you going to have to replace the filter material. So it's real important to do what you can to minimize that sediment load going into the bioretention system. So these are looking at some of the standard, your typical maintenance activities. Obviously, the pruning and weeding to maintain appearance. This is more of an aesthetic maintenance activity. Mulch replacement when erosion is evident. Clarify on that. That's really, you want to make sure that these systems are inspected regularly. And we'll look at this next slide, which is a sample operation and maintenance plan. And I'm sure most of the cities, most of the folks here, when you have a wet detention pond for a subdivision or for a retail development that's not located within public right-of-way, you typically have them submit an operation and maintenance plan. This is a sample from North Carolina, and it's fairly simple. It's not, in all honesty, it's not really that much different than the maintenance of a detention pond. And the main goal is to make sure that you're removing any of that sediment load that gets it into your system on a regular basis. And again, I'll go back to it. We want to make sure that these things are designed where that sediment load is low. And the design example shown, we're looking at the gravel diaphragm. Any means possible that you can really spread that flow out. When it's a constricted site and you can't spread the flow out as well, you want to make sure that you have a forebay incorporated into the design. But all in all, if you're really just treating the runoff from a parking lot, your sediment load shouldn't be expected to be that high, versus if you have it immediately downstream of a disturbed area. So really easy things you can do: let it filter over grass strips, let it filter through a vegetated swell, or install some kind of forebay system to make sure that you're reducing that load. In your handout, you do have some examples from Prince George's County. You have a sequence of construction for bioretention, the bioretention inspection checklist, and the plan review checklist. And the sequence of construction that's shown, I'm going to flip to it here, is really just a general purpose sequence for construction. It's going to depend on the exact type of system that you're installing. So you want to be real careful of that some are going to be constructed in a different manner than others. But this just really gives you a general overview of what you're going to look at. In my experience, these systems go in fairly quickly. And because they go in so fast, you want to make sure that you have coordination with the contractors out there, that they're not building them so quickly that they're not considering the fact that everything around it is disturbed soil. Because you want to protect it, you'll most likely have your bioretention basin constructed before anything else, before you have any grass established. So you want to make sure that there's plans to protect that system while you've still got ongoing construction around it. But they're generally installed fairly quickly, just a couple days. I think we had 5 installations in a day and a half. That's not including establishing the vegetation, obviously. That's just getting the system in, getting it wrapped with the filter material, and getting the backfill in. So it's a pretty quick process. The next item in the handout is the bioretention plan review checklist. And it's very similar to reviewing storm drainage plans. If you're just looking at your standard wet ponds, dry ponds, the main thing, again, I keep harping on this, is you want to make sure that there are systems in place that are going to reduce that concentrated flow into that bioretention system, and thus reduce the potential for a lot of sediment buildup. That comes into play in the plan layout. And in the back of this, at the end of this checklist, you really get into just your design computations. And if we did have a checklist that's based on ISWIM, obviously we'd be referencing the ISWIM computations. Anyone have any questions on these handouts? I know we could have a question if it was something that was in ISWIM. But I think it's fairly general, fairly basic, and you can, the technical part of it really is going to be reviewing those water quality calculations. Everything else is really going to be similar to reviewing a standard retention